Good afternoon, everyone. Today we're going to find the area of a quadrilateral ABCD with the information given in this diagram. So first of all, we can notice that we don't have any right angle triangles, right? So we know we're probably going to have to rely on non-right angle trigonometry, okay? So first things first, we can notice that in triangle ABD, we are given two side lengths and the angle in between, right? Now, if you've studied the sine law and the cosine law, you'll remember that anytime we have two side lengths and the angle in between them, this is a likely candidate for the cosine law. So we can go ahead and find, let's call this BD, right? The line segment from B to D, okay? I'm not entirely sure if this is necessary, but this is the first part of the puzzle that kind of jumps out at me. So let's try it. So using cosine law, we can say that BD squared is equal to 125 squared plus 120 squared minus 2 times 125 times 120 times the cosine of 75 degrees, right? Our basic cosine law. And then, of course, that means that BD is equal to the square root of all that. And I'll let you do that on your own calculator. So that'll be the square root of 125 squared plus 120 squared minus 250 times 120 times cosine of 75, which is 149.2 meters. So that's our BD, 149.2 meters. And I'll remind you that we have a very general formula for the area of a triangle. That is that the area of a triangle is equal to 1/2, not simply base times height, but in a more general sense, A times B times the sine of C, where C is the angle between A and B. Between A and, oh, that's an awful ampersand, and B, okay? So, with that information in mind, we can now for sure get the area of the triangle ABD rather, ABD, because we have all three sides. Even before getting BD, we could have actually still gotten the area of that triangle by 1/2, 125 times 120 times the sine of 75, but we'll likely need BD to finish off triangle BCD, and that's exactly what we'll have to do. So now BCD, we have two side lengths. We have BD, 149.2, we have CD, 90, and we have the angle in between, which is precisely how our area of the triangle formula is written out. And so right away, we know that we can find our triangle area, right? Our area of the quadrilateral is going to be the area of triangle ABD plus, of course, the triangle, the area of the triangle BCD, which means 1/2 ABD is going to have area 1/2 AB sine C, so 125 times 120 times sine of 75 degrees plus triangle BCD using these two side lengths, and the angle in between is again 1/2 149.2 times 90 times the sine of 30 degrees. For those of you that are familiar with the unit circle, you know that sine of 30 is simply 1/2, right? So that'll be an easy enough calculation to run through. And let's go ahead, sine of 75 is an irrational number, so let's go ahead and calculate that out. So we have 125 times 60 times sine of 75 plus 22.5, 29.2. So we are at an area of 10,601.44 square meters. And we're done. Yep. So simple enough. Again, just using the cosine law. Cosine law is a very suitable, let's say, formula. Whenever we have two sides and the angle between those two sides of a non-right angle triangle, the sine law is more if we have, let's say, this information, but if we were looking for, no, the sine law would be useful if we had an angle and its opposite side length. And then we were looking for one of the other angles or one of the other side lengths. But since we don't have the side length opposite to 75 degrees, the sine law really would not come in handy. And we don't have the angles opposite to either of the side lengths we do have, so again, the sine law would not come in handy. So, mixture of the cosine law with our general formula of the area triangle, and we're done. So, I hope this helps. Thanks for watching. If you guys have any questions, comments, suggestions, please let me know. Take care.